Good day, ladies and gentlemen. This is Sarah van Grienen, aka Mr. VG, and we are now deep into paper 1, working through the 2021 exam paper, the November exam written by the Department of Basic Education students. And in this specific video, we are going to look at quadratic sequences, which is what Q3 or question 3 is all about. But I encourage you to not just go, oh sir, you know, I know quadratic sequences, I've seen it like a million times. I encourage you, watch this video from beginning to end, because I'm going to share some amazing little secrets for you that you've got to look out for when looking for quadratic sequences and series. But before we get to those secrets, I encourage you again, go and hit the pause button, work through this question yourself, then come back at the end of that and watch the rest of the video. When I look at this one, question 3 states, consider the quadratic pattern. Very, very important, quadratic pattern. That means there must be a constant second difference that's not equal to 0. Okay, I just like to specify the not equal to 0, because if you've got even an arithmetic series or sequence, they also have a second difference, but the second difference is actually equal to 0. Just some random little bit of information there for you. Might need to use it at some party for some trick. But let's quickly now go to this constant second difference. For me to answer question 3.1, I like to write out my terms. So negative 145, negative 122, negative 100. Now please, grade 12s, be careful. Don't rush through this. I've seen so many students mess this up because they, it's easy, sir. Then they get the signs wrong. So I like to write it out. Negative 122 minus negative 145. That means that is 23. So in other words, I'm actually adding 23 from negative 145 to negative 122. I'm going to repeat this process. And now I'm adding 21. Now to get the second difference, I say the 21 minus the 23, which means there's a constant second difference of negative 2. How do I know it's constant? Remember, we're talking about a quadratic pattern. So for me to answer question 3.1, I must actually look at going on with that. So in other words, from 23 to 21, I subtract 2. Again, from 21 to get to the next difference, I must also subtract 2, and that's where the 19 comes from. Which means I've got to take the negative 101, add 19, and that is my fourth term, negative 82. Yes! Please, 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 matrix, make sure your signs are right. Now, when we look at question 3.2, it's always good to just again, for myself, redraw my differences. The question is, prove that Tn is equal to negative n squared plus 26n minus 170. In other words, that's what I need to get. But please, ladies and gents, ignore what it is equal to. You are going to get 0 marks if you just substitute 1 in and get 145. Substitute 2 in, get negative 122. Substitute, you will get 0. You have to ignore what they're asking you to get it equal to, and just in your final answer, you check, is this actually right or not? Please, please, please be careful. So they're asking me to do the general term. So if I go and find the general term, remember the yellow brick road. 2a must be negative 2, 3a plus b must be 23, a plus b plus c must be negative 145. Here I've got my three equations that I need to solve. Firstly, I'm going to solve a. So I'm going to divide by 2, and this I love because I've got a to be negative 1. Yes! Now I substitute in to solve for b. Solving for b, I've got b as being 26 because I'm transposing that. Negative 3, I'm transposing that, and I'm adding it on the right. I hope you find this easy. But again, what I love to do is just check, is this what I should be getting? Yes, it's 26. I love it. Now let's look at solving C. When I'm solving for C, transposing my 26 and my negative 1, so my answer is negative 170. Yes, I love this. So therefore, Tn is equal to negative n squared plus 26n plus or minus 170. So a very important thing is, even if you couldn't do 3.2, remember, you can use it to answer 3.3 and 3.4. Now let's have a look at that lovely next question, question 3.3. Between which two terms will there be a difference of negative 121? When I look at this, ladies and gentlemen, a difference. So we're not just working with a normal initial term, but we are working with the difference. So what sequence are we now working with? Well, we're working with a 23, 21, and 19. But so this is an arithmetic sequence, which means I've got Tn and Sn to choose from. Now, what are they asking me for? Between which two terms will the difference be? So we're not adding the different terms. So it's definitely not Sn. So I've got to work with Tn. So I'm going to work with that Tn, and I'm going to substitute my A and my D, A being 23, and D being negative 2. Remember, now I'm ignoring for the moment that it's a quadratic sequence, and I'm just looking at the differences. But what did they tell me? What must the difference be equal to? It must be negative 121. Now, ladies and gents, I must solve this equation. So I'm going to get n alone by transposing all the constants, and I'm going to divide by negative 2. Which means that n is 63. This means the 63rd term in the differences will be equal to negative 121. Now let's go on to the next slide, because I first want to, help you to actually answer this question by looking at this pattern. If I look at this, and I draw it out again. I love to draw it out. I'm going to say, well, the 63rd term, so there's 63 terms from the 23 to negative 121. But let's just do my magic. Let's work with term 1, term 2, and term 3. Then if I subtract those terms, look at the pattern that forms. If I take term 2 and I subtract term 1, I get the first term of my first difference. And if I repeat this process, term 3 minus term 2, that gives me term 2. So term 3 is going to be T3 or T4 minus T3. If I now expand this, and you see I've written it down, T63 is going to be T64 minus T63. So the actual answer to the question, remember what the question was. The question is, between which two terms will the difference be negative 121? And the answer, between the 64th and 63rd term. I hope you understand that. Go and revisit this. Look at the pattern that forms. That if I want T3, I take T4 minus the other term 3. So if I've got T63 there, it is term 64 minus T63. Go and rewatch this if you are a bit unsure, and please make sure that you get this right, because they love to ask this. Now let's move on to the next question. Now the next question, question 3.4, is an awesome question, i.e. a bit weird, a little bit on the weird side. What value must be added to each term in the number pattern so that the value of the maximum term in the new number pattern formed will be 1? This is kind of a what question. So let's break it down. And I love to look at the important things, the things that bring me meaning in this. The important thing that we've got to look at is that term where it says maximum. Now, if I look at the sequence where this comes from, Tn being negative n squared plus 26n minus 170. Remember, that is your original sequence. If I look at the word the terminology maximum, let's think about what kind of a sequence is this? Well, it's a parabola. And where is the parabola at a maximum? At its turning point. So what is the question behind the question? The question behind the question is actually, what is the maximum of the parabola? What is the turning point of the parabola? If I look at the turning point of the parabola, well, that is going to be x equal to negative b over 2a. Now, what did I do wrong here? A small little thing. But remember, it's not x, it's n equal to, because I'm working with n's. But this means the 13th term will be the maximum. Let that sink in. This is an upside down parabola. It becomes larger. At some point it starts turning, and then it becomes smaller again. So at the 13th term, there'll be a maximum, which means the actual value of the 13th term is important to me. So the actual value of the 13th term is negative 1, which means the maximum value of the original sequence is negative 1. But now we look at the new question. The new question is, when will the maximum be 1? So what must I do from negative 1? Remember, the question is add it. So what must I add negative 1 to get to positive 1? Come on, Matrix, you can do it. I must add 2. So in other words, if I add 2 to every single sequence or every single term in the sequence, I'm going to get a maximum of 1. I'm basically translating my whole parabola upwards 2 units. So let me just draw that. Now, I feel like I want to draw this for you. So in a nutshell, what I'm basically saying to you is the following. if there's my parabola, it kind of looks like this. It's got a highest value at -1. Why do I not do a solid line? The reason why I don't do a solid line matrix is because it's not a continuous graph. N is an element of natural numbers, meaning n can be 1, 2, 3. But that's not the most important thing. I want this maximum to be at +1. So in other words, how am I going to get my graph to be there? I am going to add 2 units. So let's finish off the sum quickly. Therefore, I need to add 2 to each term, and then the maximum will be 1. Oh my goodness, this was an absolutely gorgeous question. I loved it. I hope you loved it too. Ladies and gentlemen, please sign in to our next video where we are going to continue with sequences and series looking at geometric sequences. So have a beautiful, amazing rest of your day. Keep well. This is Mr. VG signing out. Cheers.